The first step in the design process for any robot is a risk assessment of its potential hazards. Studies have shown that most injuries occur not during normal operation, but during times when human interaction is most prevalent: programming, testing, inspection, and repair. By system design, robots rarely need human interaction during normal use and operation. But when programming, testing, inspection, or repair is required, humans are more likely to be in the robot's work area or work envelope. Unauthorized access to the robot's work envelope can be hazardous to personnel. Several methods can be used to protect the work envelope. The simplest are known as awareness devices. These devices are only intended to define the work envelope and make personnel aware of the hazards. They do not prevent access and usually consist of small fences or roped-off areas. Guarding methods are used to prevent unauthorized access to the work envelope. The simplest is known as the fixed barrier method, such as a fence or wall. The physical barrier is put around the work area and is configured in such a way that prevents access through, over, or around without a special key or access code. Another method of protecting the robot's work envelope employs the use of presence sensing devices. These devices detect the entry of a person into a hazardous area and slow or stop the robot. Pressure mats are typically installed just outside the robot's work envelope. When a person steps on the mat, a signal is sent to the robot to stop or slow work. Safety light curtains are another type of presence sensing device. When a person enters the work envelope, the light beam is interrupted, which sends a signal to the robot. For certain work scenarios, sudden stops could cause the work to become uncontained. Objects may continue to move even after the robot stops. In these cases, emergency braking of the robot is used in lieu of completely stopping. With emergency braking, the robot slows down work and does not stop suddenly. Another type of light barrier is called a single-beam photoelectric safety switch. These work in the same way as a light curtain but have only one beam of light, similar to an automatic garage door sensor. Single beams can be useful for preventing unplanned or surprise access to the work area. However, depending on their placement, single beam lights may not stop a determined person from gaining unauthorized access and potentially causing damage to the robot or personnel. The design and location of control panels are also fundamental to a safe robotic design. The control panel should always be located outside of the work envelope but within sight of the robot. Emergency stops should be located in all zones where needed and should be a large part of emergency personnel training. If the proper safety measures are used, robots can be a highly efficient, safe way to accomplish work.